This is chapter 13, section 4. We're going to talk about color and polarization. So what we're going to do is we're going to recognize how additive colors affect the color of light and how pigments affect the color of light. And we're going to explain how linearly polarized light is formed and detected. So when light shines from the sun, we call it white light, and it includes all the colors in the spectrum. So each of these colors, when added together as light, are called the additive colors. So if you remember, we had that picture before where we had this white light essentially coming in, and it came into a prism, right? And out the other side, we got all these different colors coming out. And so on and so forth. And so we know that white light is made up of all these different colors. So that's why they're called additive colors. Okay? Because if you shine a light of just that color, they add up, and when you add all of them, you get the color white, the light that we get from the sun that includes all the colors. So they add up to be that color. So the three pieces of light are this red, blue, and green. And these colors here have names too, so let me write these down for you, okay? So this one might be obvious. This one is yellow, okay? This one is called cyan, and this one is called magenta. Oops, I forgot this N here. Cyan. There we go. Okay. So those names are going to be important so that when you see them written, you'll know. So we say that red plus blue here, red plus blue, whoops, that's backwards. Red plus blue equals magenta, right? Red plus green equals yellow. Blue plus green equals cyan. So now that we've talked about additive colors, the next is something called pigments, okay? So when we mix paints, okay, so when we have a color that's not light, okay, we call that a pigment. So the colors don't add up the same way. So this has to do with the way that light reflects off of objects that is seen. And the adding of these pigments to form colors is called subtractive colors. So this is the example of subtractive colors. So when you add up subtractive colors, you end up with black in the end. And this is because subtractive colors absorb light, so they take it inside of them. And they only reflect one color, which is the color that you see. So here, again, we've got cyan, magenta, and yellow. And cyan plus yellow is green. Cyan and magenta is blue. And magenta and yellow is red. And all of those together make black. So let's look at an example of how that works. So here is our example, okay? So when you see the color red, what is actually happening is that the other colors are being absorbed. So every color is absorbed by a pigment except the color that you see. So the red here is what gets reflected. When you see green things, then what's happening is it's absorbing all colors except green, and green is reflected. So this is what happens in a leaf. Leaves and chlorophyll absorb all the colors except green light, and so green is reflected off, and that's what we see. So if you took these two and mixed them, right, this one absorbs red light and this one absorbs green light, so, and they both absorb blue. So what happens if you mix those two is you get black, because now they absorb all the colors. And this is how all the subtractive colors work. You guys will get a chance to practice this in class. So the last thing we need to talk about is called polarization. And this comes from light waves oscillating in random directions when they shine from the sun or other sources. So remember, waves are kind of transverse waves. They go back and forth like that, okay? But they can be in this plane, or they can be in this one, or this one, or this one, and this one. And so we can kind of show it like this, where it's oscillating in all the different directions. But we can do something called polarizing light waves, okay? So in polarized light, all the light waves oscillate in the same direction. So here we've got unpolarized light, and you can imagine that this is some wave going off, and this is some wave going off. And we're looking at the wave from the end. Okay, and if we use something called a polarizer, then we're only going to get the light that moves in one direction. So we can polarize light in two ways. If we reflect it off a surface, it causes polarization. So some light will be absorbed by a medium and other waves will be reflected. So reflected light consists of polarized light waves. So here it's unpolarized, it comes through. Some of the waves go through, others are reflected, but all the ones that come out, they are all polarized. They all just oscillate in one direction only. So that's one way to polarize light. The second way to polarize light is to use a polarizing filter. So a filter allows only light waves oscillating in one direction to pass through. So you've got all this unpolarized light and it hits the polarizer and it comes through and you just get the vertical or whatever direction polarized light. So that is the end of 13.4. Let me know if you have any questions and we'll do lots of demos of this one in class. See you there.